Hello everyone, my name is Abhishek and welcome back to my channel. There is a lot of discussion about DevOps engineering and platform engineering. Should platform engineers replace DevOps engineers? Or should a company hire both DevOps engineers as well as platform engineers? Or should DevOps engineers step up and address the challenges of platform engineering? While this is a very interesting discussion and you will get the answer by the end of this video, one thing that I can tell you at this point is that it's very difficult to build a platform engineering team within an organization because platform engineering is a very rare skill where you need to find people with the expertise of development, at the same time, a good understanding of DevOps. So usually companies find it very difficult to build a platform engineering team, and that too when your entire organization should use the platform that is built by the platform engineering team. The platform has to be robust, it has to be scalable, it has to be highly available. So it makes building a platform engineering team very difficult for the organizations. In this video, I will introduce you all to a platform that helps DevOps engineers take up the role of platform engineers as well. So this platform that we are going to learn today will make creating internal developer platforms very simple. So make sure you watch this video till the end if you are a DevOps engineer, or if you are building DevOps culture in your organization, this video is a must watch. Cool. So before we get started, let's try to understand what exactly is platform engineering. So platform engineering is basically a culture where platform engineers are responsible for setting up internal developer platforms, where these internal developer platforms aims at making the developers self-sufficient. It comes with a basic principle that you build it and you run it. What does this mean? Let me make it even more simple. So platform engineering team is basically responsible for setting up some workflows or creating internal developer portals, basically some internal portal where that portal should allow the developers to build their application. That portal should have the workflows where developer can click a button and deploy their application, deploy the required infrastructure without knowing what is happening under the hood. So a developer should be abstracted from all of that. Developer goes to the internal developer platform, clicks a button and gets the required EC2 instance. Or developer clicks a button and the developer's application is containerized. Developer clicks a button and the developer's application is built, CI/CD is executed, and it is deployed on a EKS cluster. Everything is done through this common internal developer platform. So one internal developer platform for the entire organization, where all the developers from different teams, different orgs use this internal developer platform. Let's understand how was the life before platform engineering. So the usual setup is that the developers, let's say they need a EC2 instance. So they go to Jira, they file a ticket in Jira requesting that they need EC2 instance. It goes into the backlog of the DevOps engineering team, where depending upon the priority, depending upon the number of requests that DevOps engineering team has, they will approach this Jira ticket and eventually they will create the EC2 instance and reply on the Jira ticket or send a notification to the developer that, hey, here is your EC2 instance. Now, this entire thing takes time, quite obviously, because DevOps engineering team is usually overloaded. So it takes some time for them. Now, what platform engineering says is that instead of doing all of these things, why don't organization build a team called platform engineering team? And this platform engineering team will create a developer portal. So it's an internal developer portal. Developers have to sign into this internal developer portal depending upon the SSO. I mean, the permissions that they have. Maybe your junior developers can be restricted access. Senior developers might be given access, whatever your RBAC is. So the developers goes to this portal and let's say the portal has multiple pages. One of the page is AWS, where they go to AWS. They provide some options in the drop down fields or they click on some radio buttons and immediately the scripts or the workflows that are set up by the DevOps team gets triggered automatically. Here, if the EC2 instance, DevOps team is creating using Terraform, let's say, or creating using CloudFormation template. Once they click on the button, the workflow, the CFT or the Terraform gets triggered and it creates the EC2 instance. Now, this entire process is automated. And some people argue here that what is the requirement of the DevOps team? So this particular workflows or the scripts that are getting executed under the hood can be developed by platform engineers itself. Now, this is a arguable discussion because companies already have invested a lot in building a team that set up their infrastructure as code. Companies already have a lot of Terraform scripts. Companies have set up CI/CD pipelines. So it's a discussion where do you really need both platform engineering team, DevOps engineering team, or should platform engineering team do all of it? Now, as I mentioned, the biggest challenge is that you create this internal developer platforms. That is platform engineering team creating the IDPs. Now, the main problem is that imagine Amazon. So Amazon might have some 10,000 developers and all of these developers will depend upon this developer platform. If a company builds platform engineering culture, so this developer platform has to be highly scalable. It has to be highly available. It has to be very robust with very less downtime, if required, zero downtime. And the platform engineers should be having knowledge of JavaScript. They should have idea of building the platforms. At the same time, they should also have the knowledge of DevOps. So this is the bottleneck. This is where organizations find building platform engineering team highly difficult. In this video, we will use a platform called Kestra. So Kestra is a platform where DevOps engineers can use the platform Kestra and by just having knowledge of YAML. Kestra has thousands of plugins, integration with Terraform, integration with GitHub, integration with AWS. So DevOps engineers can just download, install and set up Kestra on AWS platform or anywhere by using YAML and the plugins provided by Kestra. They can set up this internal developer platform, and this internal developer platform without zero coding skills can easily make the developers self-sufficient. You might ask, but Abhishek, even if we go to the previous example, there are platforms like Backstage, right? So Backstage is a quite popular thing in the world of platform engineering, where Backstage can help you build internal developer platforms. While this is true, but learning Backstage itself is a very steep curve. You need to have a good amount of understanding of JavaScript. You need to have good amount of understanding of TypeScripts, and learning the Backstage plugins is also a steep learning curve. I'll make a detailed video on Backstage later where I will cover the advantages, at the same time disadvantages as well as the cons. But anyone who has worked with Backstage, they can tell you that it's not a easy thing to onboard. Initially, you might find it easy, but when you take Backstage to a scale, or the IDP that you have built with Backstage to a scale, you will start seeing the real issues. And moreover, a lot of companies already have their Terraform scripts. A lot of companies already have their CI/CD pipelines, except for the startups, companies that are just starting. So people already have invested in creating this, and Backstage plugins are not super compatible with your existing scripts. So to solve all this, the Kestra platform, which is our virtual platform engineer, can upskill the DevOps engineers, can take the DevOps engineers to the next step where DevOps engineers are already doing the job of IAC. They are already creating the Kubernetes clusters, deploying everything that a DevOps engineer does. On top of that, just by having the knowledge of YAML and understanding the Kestra plugins, which is just reading the documentation, they can upskill the DevOps engineers to platform engineering roles. And no need to build the internal developer platform. Kestra platform itself can act as a internal developer platform, and you don't have to worry about scaling of the platform. You don't have to worry about high availability of the platform. You don't have to worry about robustness of the platform, because Kestra is a complete open source platform, and they also have a SaaS offering. So if you get the SaaS offering, you can definitely contact their support. Otherwise, their open source solution is also quite robust. Cool. So enough of discussion. Let's understand how to do this now. So Abhishek, you explained that Kestra is self-sufficient for DevOps engineers. It can be used as an internal developer platform. You can create the required workflows. Can we see that in action? Yes. Now let's go ahead, install Kestra, use it, and learn how to set up the workflows. Okay, let's head to the Kestra official website, kestra.io. And as you can see, so it can help you create the workflows where you can track the execution of your workflows. You can see when exactly your workflow has failed, what is the reason for it. You can look at the analytics, track the metrics. Along with that, you can also see logs of your executions. One thing I really like about Kestra is their plugin support. It has support for almost everything. You can go to AWS, and just using Kestra plugins, you can create any resource on AWS. And as a DevOps engineering team, let's say you have your Terraform files or the Terraform scripts that you have written. You can leverage your existing Terraform scripts with the Kestra workflows. So this is what I was talking about. Kestra as a platform and the Terraform scripts that are written by the DevOps engineers can integrate and work as an internal developer platform for your developers. So now let's go to the documentation and see how to install Kestra. I will use Docker Compose in this video because I'm running a local instance of Kestra. If you want to set up Kestra at your organization level, or let's say you want to put this in your production, you can also run Kestra on a EC2 instance and connect it with Amazon RDS along with S3. So this becomes your production level Kestra instance that you can share across your organization. I'll also put this link in the description so that if you want to set up Kestra at production, you can take a look. Going back, Docker Compose, let's copy the Docker Compose file and let's take the terminal, run the curl command. So now we have the Docker Compose file where the Docker Compose file is basically setting up a couple of services. One is the Postgres and other is the Kestra main component. Let's run Docker Compose up. And if you want to run this in background, you can use -t. I want to look at the logs, so I'll just run Docker Compose up. It shouldn't take a lot of time. Within 30 seconds or 1 minute, you should have your Kestra instance running on your machine. So let's go to the browser, use localhost port 8080. That's it. We have our Kestra instance running. And this instance can be used as internal developer platform. It asks for enabling authentication, like you can also set up authentication where some developers can be provided access to the platform. Maybe you can restrict the access to your junior developers, or you can provide access for a couple of members in the team, however you want to set up the RBAC. And this is the complete dashboard where you can see all the workflows. You can go to a particular workflow and execute the workflow from here. You can look at the executions of the workflow. You can check the logs. And as a DevOps engineer or as an administrator of Kestra, you can also create tenants or the namespaces. For example, you work for an organization called Amazon. And within Amazon, let's say there are multiple teams. So you can create a namespace for Amazon.payments and different namespace for Amazon.catalog. And again, you can use RBAC to make sure people in payments cannot access the infrastructure of catalog or the workflows of catalog. Kestra also provides blueprints. This makes getting started with Kestra super easy. It took less than an hour for me to get started with Kestra because their blueprints are super easy. If I want to create a S3 bucket, let's say, I just search for S3. There is a workflow already which explains how to create S3 bucket. Or if I want to integrate with my existing Terraform files, they also have a blueprint for that. CI/CD, Kubernetes, everything. Okay, now let's go to the dashboard and let's set up our very first workflow. What we will do is we will create a basic workflow where we will learn how to create S3 bucket on AWS, create a resource on AWS and share that workflow with our developers. This is our first workflow. As I told you, I can also just go to the blueprints and search for the S3 workflow and click on use. In Kestra, there are 4 things that you should keep a note of. If I just go back to my notepad, the first thing is metadata. If you know these 4 things, you can set up any workflow in Kestra. First thing is metadata, where you provide ID for your workflow and define a namespace. This becomes your first section of Kestra. The second section is inputs, variabilizing your Kestra workflow. If a developer wants to execute a workflow, and during the time of execution, if you want developers to provide inputs, for example, name of the S3 bucket, or maybe name of the EC2 instance, or pass some inputs to create an EC2 instance, you can take that in the input sections. Then you have the most important thing, that is the tasks. Within the task, for every task that you create in Kestra, again you provide a name and you provide the type. Type is nothing but the plugin that you want to use. Kestra has plugin support for almost everything. So you just need to go to the docs and identify which plugin that you want to use. Do you want to use a Terraform plugin and run your Terraform script? Do you want to use Ansible plugin, Kubernetes? Just go to the docs and take a look at it. Finally, the output section. Post execution, if you want developers to see something on the screen, so you can just provide that in the output section. Developer has requested for a S3 bucket, so you can provide in the outputs a confirmation and the URL of the S3 bucket. Or developer has requested for execution of a CI/CD pipeline. In the outputs, you can just mention the pod name that got deployed on the Kubernetes cluster, or the service URL, or the load balancer URL, ingress URL. That's it. If you know these things, you know Kestra. You don't need to know anything additional. And now you might believe me that a DevOps engineer can upskill and do the responsibility of a platform engineer as well. If you still have doubt, let me create our very first workflow. I use the blueprint, and the blueprint also has the same thing. First ID, create bucket flow. You can make it elaborated, call it create S3 bucket flow. Name of the company, let's call it as company name as example, and the project name as products. We are taking input from the developer where we want to ask the developer what is the name of the bucket. And Kestra also has integrated the documentation into this IDE or the developer environment. If you hover over a particular field, you can see the documentation of that particular field. Let's say I hover over the task. You can see what's inside the task and what are the different fields, right? Cool. So bucket name, the type is string. Do you want to put any default value for the bucket name? Let's provide any default name in case developer forgets to provide a value. If you don't want any default, you can remove that as well. And you can mention if a particular field is required or not. Is it a mandatory field? Is it an optional field for the developer to provide? And in the task, first provide ID for the task, create S3 bucket. And this is the plugin that we were talking about. What is the type of the plugin? Type of the plugin is AWS S3 create bucket. It's very simple. Even if I remove this line and if I just say type and just write S3, there is a auto completion feature where it will ask you, do you want to create a bucket? Do you want to delete a bucket? Do you want to upload the contents to a bucket? I want to create a bucket. And then you can also see the examples to your right side. If you want to create S3 bucket, Kestra says these are some of the examples where you can create S3 bucket with AWS access keys, or you can create S3 bucket in different ways. And what is each field exactly doing? Access key ID, I cannot put it here, so I will need to define a secret. I will also show you how to define this secret. So AWS access key ID, AWS secret key ID, region where I want to create the S3 bucket. Let's say I want developers to create buckets only in the US East one. I can hard code it. And this is the input that we are taking, which is the bucket name from the developers. Cool. So now the thing is, how do we configure this AWS access key ID and secret access key ID? Abhishek, instead of using this workflow, can I use my Terraform script that I already have for creation of S3 bucket? Yes, that will be our next example, which I'm going to show you in a while. Let's head to AWS, go to security credentials, and let's create access key ID and secret access key. Create. I'm going to delete this in a while, so it's totally fine. What I need to do is just copy this access key, go back to my terminal. So in Kestra, what you need to do is whenever you're dealing with secrets, you need to first encode the secret, base 64 encoding. Take this, right, and go to your Docker Compose file. Go to the Kestra container, and in the environment variables section, everything that I'm talking about is available in the documentation. Their documentation is very elaborate. Now that I'm used to Kestra, I'm using it on a day-to-day basis. I find it very easy to go here, and I already know the things. Okay, so in the environment, I'll just prefix secret, right? So if we go back to our Kestra workflow, AWS underscore access underscore key ID, just prefix that and put the base 64 encoding object that we copied. So copy this, put it, prefix it with the secret. At the same time, you should also put your secret access key. Again, copy this, prefix with secret. I'll tell you why this is needed. Like, why am I prefixing the variables that I have here with secret? This is to tell Kestra that, hey, this is a secret and do not show this in the Kestra logs. So this tells the Kestra container that, okay, I'm dealing with a secret. It's not a regular environment variable. So I need to make sure whenever I find AWS access key ID, I will make sure the field is redacted and people can't see the secret value. And that's why they also use the base 64 encoding. Okay, so let's go back to the AWS, copy the access key. Let me save this and again do the base 64 encoding. Come back to the Docker Compose file and put that in the environment value, key value pair. Perfect. And let me make sure that there are no additional spaces. I don't think it would matter, but still, I just want to make sure that I don't put any extra spaces. Now, one thing that you need to do if you're using an open source version of Kestra is that you need to restart your Docker containers. So this is needed if you are dealing with open source version of Kestra. Whenever you are adding environment variables, you need to restart the containers. Why? Because the nature of containers is that they cannot dynamically pick up environment variables. When a container is running, you cannot add new environment variables to the container. This is a regular thing. So because I'm running Kestra using Docker Compose, I need to restart my containers. So again, I will just do Docker compose up. And this time the Kestra container has fetched the environment variable, which is my AWS access keys. Perfect. I believe Kestra is up and running. So I'll go back here, save this workflow, right? Now assume I have done my DevOps platform engineering thing. And now I have logged into Kestra as a developer. We haven't set up SSO, we haven't set up RBAC. So just assume that I am a developer and I have logged into Kestra. This Kestra is hosted somewhere. I'm given the URL by the DevOps team and I logged into it. Now I'll just go to the flows. So if we just scroll down, we have our create S3 bucket flow. Let's just go here, click on execute, and see this is the input value that we have provided. Now I just need to provide the input value. Kestra, Abhishek, just a random name for the S3 bucket, 001 underscore 112. And you can also provide some advanced configuration like key value pair and all. I'll just click on execute and you can see the execution. So this has failed. Let's see why. Inputs.bucket unable to find bucket used in the expression. So I modified the workflow. I called this as a bucket name. So I just need to replace the input name with bucket name. So let's save this, right? Go back to the dashboard, go back to the workflows, create S3 bucket flow, execute, provide the bucket name again, Kestra underscore Abhishek underscore 001 underscore 112. And let me click on execute. No worries, it again failed because of a simple mistake that I cannot provide the bucket name with underscore. So cool, head back to the flows. You can also restrict this. You can provide some suggestions to the developer that, hey, you cannot provide underscores. So Kestra, Abhishek, 112001, execute. This time it is successful. So after two failed executions, my Kestra workflow is successful. And this is what I was talking about. You can go to the dashboard. You can see overall that there are 3 executions and 2 times the execution has failed and 1 time the execution is successful. How can you build a better internal developer platform, right? This is super amazing. You can look at the logs. You can go back to your executions at any point of time. It provides you the suggestions. It gives you the blueprints. So this is all what a DevOps engineer needs. Okay, so let's go to our AWS account and see if it indeed create a S3 bucket. Amazon S3. So there is Kestra Abhishek 112001 and it's at the timestamp 9:05 p.m. in the Indian time. And now it's 9:06. So just a minute ago, Kestra has created the bucket for me. Awesome. So we learned how to create our very first workflow. Now the second question that you have, can I integrate my existing Terraform workflows in the same seamless way, right? It created AWS resource seamlessly. Can it also create a, let's say, a GitHub resource using my existing Terraform files? Definitely. So go to the blueprints and just search for Terraform. Create a GitHub repository with Terraform where you have an example already. And you can see here, you can replace this section with your existing Terraform files. Abhishek, what if I have a lot of Terraform files? Don't worry, you can also reference your complete Terraform project. It can be in a GitHub repository, it can be in any other source. instead of this simple Terraform file, which comes from an input file section, you can reference your Terraform project as well. And the steps are very simple. Just how we created a AWS resource. Here we are taking two inputs. One is the repository name and the description for the repository. We are creating a GitHub repository, right? And your Terraform HCL file that you have and the repository name as well as the description is passed as input to your GitHub repository resource of the GitHub provider of Terraform. And you also have to use a secret as we used AWS secrets in the previous example. Here we will use GitHub token as the input secret. And then you can provide the Terraform commands in the command section. So in the before commands, you can just say Terraform init and the actual command execution as Terraform plan, Terraform apply. In the output files, you can see what is the output of your Terraform execution. This way, you can use the Terraform plugin and you can integrate your Terraform workflows or scripts with Kestra. You can also do it with Azure. For example, just click on Azure and you can see some blueprints for Azure. But the best thing that you need to do or you can do is just go to the Kestra documentation and search for the plugins that they have. Here you can explore all the plugins as per your requirement, as per your organization requirement and use Kestra. I hope you found this video informative. Once again, what I want to convey in this video, Kestra plus DevOps engineering team can do the responsibilities of a platform engineering team. Organization does not have to build a DevOps engineering team and a platform engineering team. You can just build one team. Whether you call it as a DevOps engineering team, whether you call it as a platform engineering team, using Kestra, you just need one team. And that team does not need to have extensive coding skills. They just need to know the YAML and how to use Kestra plugins. See you all in the next video. I will provide all the required links in the description, so make sure you don't miss it. Take care. Bye-bye.